Okay, so I thought I'd make a sort of a separate segment on significant figures, but really significant figures begins in discussing measurement. So there's a picture of graduated cylinder here. It's a small one actually. It's one of the 10 mil graduates. So I just blew it up a lot. I took a picture and blew it up a lot. And we want to measure the volume, right? So we're going to look at this graduated cylinder. Remember, you always measure the volume of a liquid from the bottom of the meniscus. Oops, don't know why I didn't mark. Yeah, from the bottom of the meniscus. And the meniscus is the very bottom of this point here. And you'll see in some of the videos that I show in the lab where you use a piece of colored paper to help it change color, and you can help you see it a little bit better. But actually that one's pretty clear. And so if I wanted to measure that volume, right, what I would definitely say is it's between 4 and 5, right, because there's a 4 here and there's a 5 here. So we know the first digit of our number is going to be 4. And then after that it's decimal points, right? So you notice that there's 10 markings between the 4 and the 5. And so if there's 10 markings, I go 1, 2, 3, 4, 5. So I know that next digit is a 5. Now, and the reason I know that is because the meniscus is below here, right? The marking for 4.6. So then this is where precision comes in measurements like on a graduated cylinder or in lab. Okay, we have to guess at what the next digit is. Well, I think that most people would say it's more than halfway, but really starting at about 0.5, right? This next digit actually has a whole range of values that people might say that it is. It'd be from a 5, 6, 7, 8, and maybe even a 9, right? And often what I'll do in class is I'll have you vote. And typically it comes out between this one and this one, right? So when you record this, what do? Well, what actually you do is you would write 4.5 and then you would guess at the next number. So I would say, I don't know, 7. Oftentimes people will pick 8 as well, and which one of those is right? Turns out they're all right, because the way when we record numbers in the laboratory, the way we're trying to communicate is we write all the certain digits. So that's what that is. So there's the certain digits, and this is the first uncertain digit. Beyond that, it's not useful trying to guess what the number is because you can't see anything beyond that level. You can only see beyond the tenths level in this case and to the hundredths. But to the thousandths level is fairly meaningless because for every hundredth, there'd have to be 10 markings for you to get to the thousandth, right? So I would call this 4.57 milliliters. In terms of significant digits, right, there's 3. And I'm going to just call 3 sig figs like that. Oftentimes I'll write this to represent 3 significant figures. And so if I'm correcting your work and I write that, it means that that was the number of significant figures you should have used. Okay. Whoa, I don't know what that was. Here's a couple of more examples. Again, these are volume measurements, but I could have used something else, right? So let's look at the next example. This is 15 and that's 20. So 15, 16, 17, 18, 19, 20. So I know that this is at least 18. Now, what do you think the next digit is, right? Well, 18, like a lot of people would stop there, and it's not that that's not accurate, but it's not portraying the correct precision. So for example, let's go back to here, right? When I did this number, I could have said 4.5, but that would have meant it's either 4.5 or I was because that's, remember, if I had written 4.5, that's the 5 is the uncertain digit. It would have been 4.5, maybe 4.6, 4.4, but we know quite visibly, right, that it's not that, and that's why we had to record one uncertain digit. So when you do this, you know it's 18, but if you leave it at that, remember, if this is recording significant figures, that would be the uncertain digit. And so that means it could have been a 7, an 8, or a 9, right? But in fact, what you're trying to convey is it's right on the line, so we would have called that 18.0 milliliters, like that, okay? And the same thing happened here. We conveyed the 7. That was the first uncertain digit, where we had to guess a little bit. This one doesn't look so much like guessing, so it's a little bit harder, actually. This particular example catches a lot of people because it doesn't look like it should be that hard. And it should just be 18, but if you want to convey it correctly, you have to add the 0.0. So again, this one has 3 significant figures. Let's do this one. This is this next one over here. I think I photoshopped this one, actually. So you have to write at least, it's 5, right? And then we know it's between 5.0 and 5.1, so we would say 5.0. And then we have to guess at the next digit, right? So this looks like, and you can write this down without me saying it, but it looks like it's about 0.6 or 0.7 again. So I'll say 5.07, and again, the units would be milliliters. This again would have 3 significant digits because you count the certain digits and the first uncertain digit. So 3 for that particular number. Okay, so it comes down to, often in the laboratory, people get confused by these. All right, so there's some examples of balances that you might see in the classroom. They show you numbers, right? They don't show a scale. I have another balance at home here somewhere. I don't know where I put it, but it has a scale on it, and you have to sort of guess what the mass is. But in a digital balance, right, when you're given digits, you have to just record all of them. They're all significant digits. So this particular one, this would be all the certain digits. That would be the 1 and the 0, and the first uncertain digit is the 2. So this one's 3 significant figures. And the one on the bottom, we ignore all these zeros that are in the front and just start with the first number and go to the right. So it turns out this one's 3 as well. And I just realized I think all my numbers had 3 significant figures. Yeah, they did. Okay, well, I'll change some later to make sure we don't do that. So understanding, when you write a number, you get your certain digits and you write them, and then you estimate the next one. That's how we do it in the laboratory. So when you get a number, how do you interpret it, right? So these are the rules for significant figures. Non-zero digits, trapped zeros, and trailing zeros with a decimal are significant. So basically, these are known as trapped. They're between 2 non-zero digits. Now, for sure, when you see non-zero digits in a number, in a measurement, those are significant. The zeros that are between them are also significant. So there's 4 in this one, right? So if you look at the next number, right, these are known as trailing. And they're only there to hold the place of the number because it could have been written as 1.24 times 10 to the 4th kilograms, like that. And those zeros go away because they were just placeholders. So, having said that, when you read this number, again, this is 3 significant figures. So what I want you to do is think about these next 3, and then I'll write the answers out. But for the first one I'm having you do on your own, 0.0056, convert that to scientific notation, and tell me what you think the number of significant figures is. So I'll pause it, and then I'm going to actually fill it all in, and then we can just talk about it. Okay, so there are the answers. When I convert to scientific notation, that goes to 5.6 times 10 to the minus third, so there's 2 significant figures in there. On the other hand, 95.0, and this is one that tricks people. This is known as a trailing decimal, 0 with a decimal. That's what this statement is here. That actually counts then, and so that's 3 significant figures. Now, why, right? you wouldn't have written that. 0 does nothing for you. It's not holding a place though. So why does that matter? Why is it the significant figure, right? It's because you wrote it down for a reason. You could have had 95, and if there wasn't a reason to write the 0, you don't necessarily have to write it. But if it's the last significant figure, right, the first uncertain digit, then you would have to write it to convey it. Okay, so that's kind of the idea of that decimal thing. If you have a decimal and you put a 0 to the right of it, you didn't have to write that. So if you wrote it, it must be significant. This one is a little bit easier, 3.08. That's 3 significant figures. All right, so let's talk a little bit about calculations with significant figures, and then we'll have a slide with some practice calculations and go over those. So when you're doing calculations with significant figures, there's really two things that you have to keep track of. Whether or not you're doing multiplication and division or things like that, like powers and roots, those all fall in the same category. And then whether or not you're doing addition or subtraction. And when you do operations like multiplication, you keep track of relative precision. So basically what that means is you look at the number of significant figures the different numbers have, and then you always keep the least number of significant figures. So when you multiply, relative precision is important. And basically, you keep track of the lowest number of significant figures in the answer. So, for example, in this, problem is not a slide, is it? Put it as a slide. When you're looking at the multiplication of these two numbers, it's 107,500 times 165. Well, this has 3 significant figures in it. Sorry. There we go, 3. And this one has actually 4. These zeros are trailing, so they don't count. So you have to go over those rules, make sure you understand that. That means you can only keep 3 significant figures in your answer if you're rounding it. Okay, so what I'm going to do is this. I count from the left. This is 1, 2, and this is the 3rd digit. The rest of this stuff is not significant. So what I would do if I had to round it at this point, I would figure out how to do it in scientific notation. 1, 2, 3, 4, 5, 6, 7. So it's 1.77 times 10 to the 7, like that. On the other hand, and again, I'm keeping track of the number of significant figures. Now, if this is not the last calculation, but it's part of a series of calculations, all you do is mark the 7, and then you go ahead and continue to do your calculation. And at the end, you only round one time. So when you add and subtract numbers, what we're actually keeping track of is known as the absolute precision. And so all you have to do is keep track of where the last significant digit is in the numbers, and you always round to the largest of the last significant digits. So for example, same two numbers, now I'm adding them, right? The last significant digit is here, and the last significant digit is here. So this is in the hundreds, right? This is in the ones. So the largest significant digit, right, of the least significant digits, so the largest of the last, right, is the 5 after the 7. So what that means is I'll take this number and round it to that place there. Okay. Now when you look at this way, it sometimes doesn't make sense. But if you look at it like this, then it kind of makes more sense. 107500, right? Plus, and remember you have to line up the numbers, so it'd be 165 like this. When you write that out, that's 107665, right? So here's the deal. This is the last significant digit, so you don't really know what those numbers are, right? So when you add these two up, you don't really know what these two are either, and so you'll round them off in the next step. So if I'm rounding this number, I would write it as 1.077 times 10 to the 5th, like that. Because you go 1, 2, 3, 4, 5. All right, so that's how you do that. Again, keep track of whether or not you're doing an addition step or multiplication step or similar, right? Multiplication, subtraction, or the same rule. And then if it's multiplication, or division, roots, and powers, then what you do is you keep track of the least number of significant digits. And if it's addition and subtraction, we're doing absolute precision. We keep the largest of the last significant digits. So let's go ahead and look at a couple examples. I worked these ones out. They have units and stuff like that. But right, I have 2.145 inches cubed, so that's a volume, times the density in grams per inch. There's an extra zero in there. Ignore that. When I upload these, I'll have that deleted, hopefully. And then that comes out to 2.574 grams. The inches cubed will cancel out like this, right? And the question is, how many significant figures? So what are we doing, right? We're doing multiplication, right? So this is 2 significant figures, and this is 4 significant figures. So this answer will be kept to 2 significant figures, like that. And so the answer becomes 2.6 grams. If we look at another couple of common types of calculations that fall under the same rule, there's squaring, right? Because that's essentially multiplying a number by itself. That gives me this number, 3.14 centimeters. If you square it, it gives you 9.8596 centimeters squared. There are 3 significant figures here. So in this answer, I would keep 3, right? That would be my 3 there. So this would be 9.86 centimeters squared. Now this last one that I'm showing you, I'm just showing you because how ridiculous calculators can be. This is how many places my calculator on the computer shows. So I take 17.95 centimeters squared, and then I'm taking the square root of it. So the unit would be centimeters because I'm taking the square root of a square. And then I have to round it. So how many significant figures? Well, it should be here because this one's 4. Okay. So what you would write down in is 4.237 centimeters, like that. Oh yeah, 7, because you're rounding it because it's 6 and the next one's a 7. Now, the reason I wanted to show this particular example, because the other two aren't too crazy to write down, don't write down this whole number. All of this is unnecessary. In fact, if you're going to do a calculation with this number later and you don't want to round it, really you only have to keep up to about this 4 and then use that in your calculator, because all those digits are not significant. That is, they don't change the value of the answer at all, or not significantly anyways. All right, so let's look at some addition and subtraction. Okay, so we have a couple of addition and subtraction examples here. So on the left over here, of 110.3 and then 7.1, we're adding them together. So the way you keep track of significant figures when the numbers are lined up like this is basically you draw a line. Oops. Draw a line like this. And you say, in which place do I see all the numbers? And that's that one there. And that's dictated by this. So you look at this last digit and you see where it is. And it's the column where you have a number for every single thing that you're adding, every single number you're adding together. And so this number would round to 144. It would have 3 significant figures in it at the end. And it's not based on the least number of significant figures. It's determined by the place. Now, most of the time you don't see numbers set up like that. In fact, most of the time people don't even write it like that to do it. What they do is they write it like we see over here, right? And so how do you do it when that's the case? Well, you do exactly the same thing. You mark the last one, and then you see which one's in the furthest place to the left, or the largest place. So this is what we mean by, absolute precision. It's actually the largest place. So that's going to be dictated by this 15.1. So this number, you notice there's a subtraction in here too. This number, right, is where I'd round to. And so this becomes 36.4, like that. Now, the one at the bottom is basically the same kind of thing. So what I want you to do is go ahead and try it, and then we'll go ahead and talk about the answer. Of course, assume that this answer is right, and then go ahead and just try to determine the place of the significant figures. Okay, so that's what I got. I looked at the 305, or sorry, the 0.035. and the 0.0367. So I know the 5 is in the thousands place. This 1 of the 411, that's in the thousands place. So this will go to the thousands place. So that's how that would round out. So hopefully you were able to do that. And yeah, hopefully we do that. And these are the kinds of things that you'll have to be able to work out in your homework. So the next thing I'd like to do is talk about how you do multiple operations. That is, if you have a bunch of mathematical steps, how do you deal with significant figures? So the simplest way for me to say it is go ahead and calculate the answer that you would normally get. Then what you do is you go back and you track through the significant figures that are in the answer at each step. Okay, so I'll show you how that works here with this one, and we'll go through a couple more complicated ones, and I'll have you guys do one, and then we'll work it out together. Okay, so we're going to calculate an answer, go back, track significant figures, and then what we'll do is we'll just track significant figures through each part of the calculation, and then at the very end we round it. So you only, in any multiple step operation, you only ever round one time, and that's at the very end as you're reporting your answer out. So I have this sort of a density type calculation. It's 12.25 grams minus 9.900 grams divided by 3.370 milliliters, and I want to calculate the answer with the correct number of significant figures. So basically what I've showed you here is what happens after each mathematical step, and then what the calculator was telling me the answers were. Okay, so this is the answer that you should get. Oop. That was nice. That's the answer you should get. If you just plug it into your calculator. Okay, so 0.6973, and the units would be grams per mils because of the way they work out over here on the left-hand side. So then the next thing is, sorry, it's my water bottle, I didn't realize in the way. Is to track sig figs at each step. So this is a subtraction step up here, right? You can put parentheses around to emphasize it. That should be good to that place there. So that number has that many significant figures. Those zeros at the end don't matter. Now you don't get rid of them, you just leave them, okay? And then what you do is you go 3.370, I just carried that over. So this actually has 4 significant figures in it, which means now that I'm doing the division here, this answer should be rounded to the third significant figure, like that. And then that becomes 0.697 grams per ml, like that. And then that's your answer. That's the way you should be working out your problems on your homework as well. You set up the problem, you do the calculation, you track significant figures, and at the end you round it and you box your answer. But I want to actually see both this answer and the rounded answer. All right, let's look at another one. This is sort of a velocity measure in inches per second. So like if a snail's running down the hallway, you know, they're not going very fast, so you can measure it. But let's say you have a ruler, right? And then you're measuring how long it goes from point A to B, and it goes 12.25 inches. Goes to 12.25 inches on the ruler and ends at 9.900 inches. I should say that's where it starts, and it ends at 12.25. And then the times are 109 seconds to get to this point, and then 25 seconds to get to this point. So the question is, how fast was he going? And I just added the factor of 2 in there so to make the calculation more interesting. So let's say you do this calculation. You go ahead and just do it like this, and you calculate, and that's what your calculator. Actually, your calculator is a whole bunch more digits over there. That's what your calculator says is the answer. So how do we know what the answer is? So we'll go back through. This is a subtraction, right? So we'll track the sig figs in there. It's to the hundredths place, right? Because the 9.9 is good to the thousandths place. So this number is actually good to this point here. This number is 2 significant figures, right? This one's 3. And then I'm going to do the subtraction on the bottom. And that comes out to be this 84.115, but that one is good to the hundredths place as well. So it's there. So this one actually has 3. Now, it doesn't look like 3 because I didn't round it, right? But it's 3 significant figures. So the number of significant figures, this is all one thing here. This is all multiplication, division, and roots and powers. All those things can be done at one time. So I have 2.0, right, which is 2 sig figs, 3 sig figs, and 3 sig figs. The answer should come out in 2 sig figs because when you multiply or divide, you always go by the least number of significant figures. So that means this answer would be 0.056, and then inches per second, like that. Okay, so this next one I want you to do on your own. We'll take a moment, go ahead and pause it and try working it out, and then what I'll do is I'll actually work it out with you on the screen, okay? Alright, so let's see how you check out against my fancy calculator here. So let me open up my fancy calculator. I'm going to go 6.33 plus 9.2, 9.12 like that. That comes out to 15.45, so I'm going to write that down, 15.45 like that. The 2.050, that's just going to get carried over. And then what I need to do is know what the answer for that step is. So again, fancy calculator, and I'm going to say 3.215 minus 2.94. And I get 0.275. Let's see. Yeah, that seems about right. So let's look at the sig fig. So that's that part, right? And then I'm going to go ahead and do the calculation that it says there, and then we'll do the sig fig. So 0.275, I'm going to multiply that by 15.45, and I'm going to divide by 2.050. And that'll give me 2.727. It's 2.07256. And now I have to go back and figure out how many significant figures there are. So this number, right, is to the hundredths, and this number is to the hundredths. So this number should be the hundredths. So there's actually 4 significant figures in there, and there's actually no extra digits written. The number that's at the bottom is 2.050, so that's 4 significant figures. And then the 0.275, let's see, 3.25, so that's to the thousandths, right? And this one's to the hundredths. So this number is really only good to the hundredths. So that means how many sig figs, right? It means there's 2 in here, which means this number should round to here, so this will be 2.1. And then I didn't have any units in that calculation. But the deal is the same process every time when you do a calculation. You just go ahead and do the calculation and then track through the number of significant figures of all the numbers going into the calculation, and at the very end you round it 1 time. Okay, so that's the answer for that one, and that's the answer for that one. So that finishes chapter 1, and the homework you'll find at the bottom of the module for chapter 1, the unit for chapter 1. As well as some other descriptive information for the chapter about what you should be learning. And if it was me, I would listen to a section of the video and then go ahead and try the problems for that section.